Yeah, can you see the first question on the board? All of you? Shaktivel, Anshul, Pavitra, Kirti, Ivan, Kalai Selvan, Mithun.
Yes, ma'am. Yes, ma'am.
Yeah, choose the correct answer. Which of the following is not the property of equipotential surface? They are concentric spheres. For uniform electric field, they can be imaginary spheres. They can be imaginary spheres. They do not cross each other. Rate of change of potential with distance on them is 0. Back side you have. Yeah, you've chosen the correct answer. Which one is the answer? Here, anybody? Shweta. Varshita Shri. B, they can be. Which of the following is not the property? All of them are the properties. And there is a condition also. See, they are concentric spheres. They can be imaginary spheres, but they have given for uniform electric field. Option C. They do not cross each other. Why? Yeah, it should be parallel lines, right? So if you have a uniform electric field, this will be the direction of electric field. And the equipotential surface should be a plane. It cannot be a concentric sphere. Concentric spheres can be for point charges. If you have a point charge, then the equipotential surface, that will be a imaginary sphere. But if it is a uniform electric field, what will be the structure that you get? You will get a plane, okay, plane wavefront, because it's parallel. You cannot have perpendicular lines. Only if you have parallel and perpendicular lines together, you can join to form a sphere. Clear? All of you? Now, next one. So please write down those who have. Did you copy the first question and the answer? Please copy. Afterwards, you will have to submit. Those who are attending online. Please copy the first answer as well as the question and answer along with the reason. Because uniform electric field, it can only be a plane. It cannot be imaginary spheres. Second question, a point charge Q is moved along a circular path around another fixed point charge. So the work done is always 0. 0 only if Q returns to its starting point. 0 only if two charges have the same magnitude. 0 only if the two charges have the same magnitude and opposite signs. Always 0. Here. Here, take. Close the door. Take a chair also. Take a chair now. A point charge Q is moved along a circular path around another fixed point charge. So you have a fixed point charge here Q, and another point charge capital Q is being moved along a circular path which is kept fixed here. So suppose you travel only a small distance, you're not covering the whole circle, even then will it be 0? Why? Equipotential surface, very good. Suppose these 2 points are taken as A and B. The potential at the point A will be equal to the potential at the point B. So it need not always complete the circle. Even if it is traveling only a part of the circle, it's only traveling an arc, even then the work done is going to be 0 because all the points are at the same potential. That is the property of equipotential surface. All the points which are at equal distances from the fixed charge, Since all are at the same distance, the potential is going to be same. So always 0, 0 only if Q returns to the starting point, not necessary. Any 2 points is also enough. Then 0 only if the two charges have the same magnitude, nothing like that. 0 only if the two charges have the same magnitude and opposite sides. Now question number 3. Yeah, very easy because previous one you solved. Are you writing the answers? So work done in carrying a charge once. Have you written the second question, all of you? Now write the third one. Work done in carrying a charge Q once round a circle of radius r with the charge Q at the center. Both the charges are Q and you're completing a perfect circle. You're reaching the same starting point. In this case also, work done is 0. Finished, all of you? Now, a tin nucleus has a charge plus 50 E. If the proton is at 10 power minus, previous question was work done in carrying a charge Q once round a circle of radius r with the charge Q at the center is. It's almost similar to the previous one, question number 2. Kirti finished? Yeah. A tin nucleus has a charge plus 50 E. What is the value of E? 1.6 into 10 to the power minus 19 coulombs. If the proton is at a distance of 10 power minus 12 meter from the nucleus, then the potential at this position is, everything is given. You calculate it. Yeah, how do you calculate potential? KQ by R. V is equal to, potential is equal to KQ by R. Others solve and find out the answer. K value. Badri, finished? Calculate.
Ma'am, is it option D?
Yes. No, not option D. 10 power 4 or 10 power 8? 7.2 into 10 power 8 you're getting.
8.
Q is 15. Yes. Check for the power of 10. Nine fives are 45, 450. 45 into 16. Option? Yeah, option A. K Q by R. Now substitute for K, 9 into 10 power 9. Instead of Q, 50 into 1.6 1.6 into 10 to the power minus 19 divided by the distance is 10 power minus 12. This becomes minus 7, 2. Then I think you will get 7.2 into 10 power 4 volt. So option
Yes, ma'am.
A. Finished all of you with steps. Can I change? Next question. Now question number 5. Two identical capacitors have the same capacitance C. One of them is charged to potential V1 and the other is charged to potential V2. Then likely charge plates are then connected. These two plates are connected. Likely in the sense, what do you mean by? Same charges. The negative is connected to negative or positive is connected to the positive. Then the decrease in energy of the combined system, what will happen to the final capacitance, final potential, charge, everything? What was the initial energy? What was the final energy? Find the difference. First, the capacitance was C. In one capacitance, the potential was V1 and the other it was V2. Then what happened? They connected the likely charged plates. Both the negatives are connected or both the positives are connected. Yes. B. How did we calculate? Decrease. So, how did you get it as B? Oh, because that one is V1 minus V2. So, when you connect a likely charge plate, what does it signify? Is it a series connection or a parallel connection? When you connect the likely charge plates, what will happen to the capacitance? Parallel connection. Positives are connected together, negatives are connected together. So it's a parallel connection. What will happen to the capacitance? Overall capacitance. Yeah, let them also try. Yeah, are you all trying? Badri. First, Tarun, your name. No, what is your Gautam? Are you trying? You are. Both have the capacitance C. But the potential of first one is V1. Potential of the second one is V2. Now the likely charge plates are connected. That was case 1. They were separate. Now you have connected the positives and negatives together, which means it's a parallel connection. What will happen to the total capacitance? Increases. C plus C, it will be 2C. And what about the potentials? They will become equal. When you connect two plates, the potential will become V1 plus V2 by 2. V1 plus V2 by 2. That will be the final potential. So initially, the energy stored in the first capacitor was, can you tell me? Separately, CV1 square. That is for the first capacitance. For the second one, plus half CV2 square. This was the initial energy. Now, what is the final energy here? Half. Instead of C, you have to write 2C. And instead of V, you should write V1 plus V2 by 2. You will get the average value. Correct. This is your final energy. Final energy minus initial energy. Calculate. Final energy minus the initial energy. Huh? B, I think. Check. B.
Ma'am, it's option D.
D.
Yes.
Yeah, check once again, ma.
Yes.
A. See, this is
Ma'am,
initial.
sorry, ma'am. It will be option A.
No, not option A. Half into 2C. What is V1 plus V2 by 2 the whole square? V1 square plus V2 square plus 2V1 V2. Then here, so this is 1 by 4 into C V1 square plus 1 by 4 C V2 square plus 1 by 4 into 2 into C into V1 V2. Now here what you have, this is your final, shall I write it here? This is your initial energy. What is the final energy? 1 by 4 C V1 square plus 1 by 4 C V2 square plus 1 by 4 into 2C into V1 V2. From this, what should you subtract? The initial energy. What was the initial energy? Half C V1 square plus, but you have to subtract. So half C V2 square. So what happens here? This becomes plus 1 by 4 V2. So V1 square difference, final minus initial. So negative, if you take it out, you'll get V1 square plus V2 square minus 2 V1 V2. This is V1 minus V2 the whole square. And what can you take common? 1 by 4 C. Take out 1 by 4 C as common. What are the terms left over? V1 square plus V2 square minus 2 V1 V2. So which is V1 minus V2 the whole square. So option B is the correct answer. Option B. First initial என்னவா இருந்ததுமா? Initially what was the energy? முதல்ல capacitance ரெண்டு எப்படி இருந்தது? தனித்தனியா இருந்தது. C1 sorry, C was having a potential V1. The second capacitance was having a potential V2. அப்போ total energy என்னவா இருந்தது? தனித்தனியா இருக்கும்போது general equation for energy stored in a capacitor is half CB square. So initial case when they were not connected, when they were separate, what was the total energy? Sum of the individual energies, that is half C V1 square plus half C V2 square. Second case la enna pandranga? Capacitance lightly charged plates are connected na, they are connected in parallel அப்படினு அர்த்தம். Parallel connect பண்ணும்போது potentials become same. வேற வேற potential இருந்திருக்கு. First plate la it was V1, second plate la V2. ரெண்டு வேற வேற potential இருக்கிறத connect பண்ணோம்னா what will happen? Till the potentials become same, charges flow ஆகும் and the potential become equal. இதுதான் நடக்கும். ரெண்டு வேற வேற potentials இருக்கிற conductors, if you connect, what will happen? They will come to an average value. V1 plus V2 by 2. ஒன்னு 7 voltல இருக்கு, இன்னொன்னு 8 voltல இருக்குனா 7 plus 8 by 2. Okay. Yeah, please switch on your cameras. Devadarshan, Saravanan. So இது தனித்தனியா இருந்த energy and இப்போ ஃபைனலா என்ன இருக்கு? You should consider it as a single system. See, ரெண்டு capacitance it is connected, and what is the total potential that you have to see. So total potential, total capacitance என்னவா இருக்கும்? They are in parallel. Parallel என்ன formula? Cp is equal to C1 plus C2. That is C plus C. Total capacitance is 2C. இப்போ second caseல என்ன பண்ணணும்? அது single system consider பண்ணணும். First வந்து தனித்தனி சிஸ்டமா இருந்தது. C தனியா, at a potential V1, இன்னொரு C தனியா at a potential V2. Now you have connected, you have only one system. And the systemத்தோட total capacitance is 2C. What about the potential? Common potential V will be equal to V1 plus V2 by 2. இப்போ நீ கண்டுபிடிக்க வேண்டியது half Cp into V, V square. Half Cp into V square. இது now it is decreased, இல்லையா? This is decreased and you have asked to find how much it has decreased. So initial இருந்த higher energy ல இருந்து இத subtract பண்ணா போறோம். Subtract. So half சொல்லுமா C initial energy half C V1 square plus half C V2 square. இது initial energy அதிகமா இருந்தது, இப்போ decrease ஆயிருக்கு. Minus half into 2C into V1 plus V2 by 2 the whole square. இனி brackets open பண்ணு. இல்ல இந்த ஸ்கொயர் பண்றல, இந்த 2 வந்து 4 காமனா வெளியில எடுத்துடலாம். 2 gets cancelled. 1/4 காமனா வெளியில எடுத்துடலாம். So minus 1/4 வரும். Then C இருக்கு. V1 plus V2 whole square. அல்ல V1 square V2 square all that gets cancelled. Halfல இருந்து ஒரு 1/4 போச்சுனா என்ன வரும்? Halfல இருந்து 1/4 போச்சுனா 1/4. So இதுல இருந்து போச்சுனா you will get 1/4 C V1 square. அப்புறம் half C V2 square வரும். And then next term என்ன வரும்? Minus here what you have 1/4 common இருந்தது C, then V1 V2 correct? 2 V1 V2 வரும். Yes, 2 V1 V2 you will get. இந்த 1/4 C was common எல்லாத்துலயும். இங்க 2 V1 V2 வரும். இப்போ 1/4 C வெளியில எடுத்துட்டேனா it is V1 square plus V2 square minus 2 V1 V2. A square plus B square minus 2AB, A minus B the whole square. So 1/4 into C into V1 minus V2 the whole square. B. Option B. Clear all of you? Minus 1/4 C காமனா வெளியில எடுத்துட்டியா? இதுக்குள்ள என்னென்ன எப்படி 1/4 C வந்தது? 2 ஸ்கொயர் பண்ணோம், அதனால 1/4 வந்துருச்சு. What is V1 plus V2 the whole square? V1 square plus V2 square plus 2 V1 V2. அது எல்லாத்துக்குமே இந்த 1/4 இருக்கு. எதுல இருந்து சப்ட்ராக்ட் பண்றோம்? ஹாஃப்ல இருந்து. ஹாஃப்ல இருந்து 1/4 போச்சுனா இனிஷியல் வேல்யூல இருந்து. இனிஷியலா இருந்த எனர்ஜில இருந்து ஃபைனலா இருக்கிற எனர்ஜியை மைனஸ் பண்றோம். So you get how much it has decreased. Okay, first 8 joules இருந்தது, இப்போ 5 joules தான் இருக்குனா how much is the decrease? 8 minus 5 3. So this is a greater value. அதுல இருந்து இப்போ lesser value சப்ட்ராக்ட் பண்றோம். So 1/4 C காமனா வெளியில எடுத்துடுறோம். இங்கேயும் 1/2 ல இருந்து 1/4 போச்சுனா 1/4 வரும் with a positive value. 1/4 C V1 square V2 square minus 1/4 C 2 V1 V2 னு வரும். இதனோட expansion. V1 plus V2 the whole square இருக்குல்லையா, அதனோட expansion. Clear all of you? Pratap, Devdarshan, Kirti.
Yes, ma'am. Yes, sir.
Now question number 6. Show that the capacitance of a spherical conductor is proportional to its radius. Hence justify that a farad is a large unit of capacitance. Are you trying? Show that the capacitance of a spherical conductor is proportional to its radius. Hence justify that a farad is a large unit of capacitance. Hemant, are you there? So what is the equation for capacitance? Capacitance C is equal to, it is the ratio of charge given to the capacitor to the potential developed in it. So Q divided by V. Now ஒரு கண்டக்டர்ல சார்ஜ் பண்ணோம்னா என்ன ஆகும்? சார்ஜ் கொடுத்தோம்னா அதோட full charge எங்க இருக்கும்? It is always spread on the surface, but you can assume that it is concentrated in the center, but it will behave like a point charge. ஒரு spherical conductorல நம்ம charge கொடுத்தோம்னா charge will be on the surface and it will அதனோட ஃபைனலா ஃபார்முலா கண்டுபிடிக்கும் போது என்ன கிடைக்குது நமக்கு? It is shown as if all the charges concentrated at the center. So point charge ஓட potential என்ன ஃபார்முலாவோ அதே ஃபார்முலா போட்டுக்கலாம். So point charge என்னது? KQ by R. That is 1 by 4 pi epsilon naught Q by R. That R goes to the numerator. KQ by R. Yes. And 4 pi epsilon naught, that also, that is 1 by, isn't it? So the final answer will be 4 pi epsilon naught into R. Now, if you need 1 farad answer varnona, radius evlo perusa irukanum, because what is the value of epsilon naught? 8.85 into 8.85 into 10 to the power minus 12. 8.85 into 10 to the power minus 12. Such a small value. So, and the value is 1 ஆக்கணும்னா 10 power 12 meters radius இருக்கணும். Only then you can compensate and make it almost equal. At least 10 power 11, 10 power 10, 10 power 11, 10 power 12. அந்த rangeல இருக்கணும் radius of the sphere that you are taking. அப்போ அவ்வளோ பெரிய amount எடுத்தாதான் you can make it 1 farad. So you are proving that 1 farad is a very large amount. 1 meter இருக்கிற sphere, you imagine 1 meter, 2 meter, 10 power 11, 1 followed by 10 zeros or 11 zeros. So much meters you require to create 1 farad, because epsilon naught is such a small value. Negative power la varudhu. Hence, so first you write C is equal to, capacitance is the ratio of charge given to the capacitor to the potential developed in it, and then in a spherical conductor it behaves like a point charge, and you can write 1 KQ by R, where K is 1 by 4 pi epsilon naught. So 4 pi epsilon naught goes to the numerator. Epsilon naught being such a small value, to compensate you require a very large value for the radius, which shows that 1 farad is a extremely large value.
Also create assumptions and then solve it.
Like what assumption? Let us assume that.
that we need a spherical capacitor to store one capacitor.
Okay.
And then we start using this one.
அப்போ ரேடியஸ் பெரிய வேல்யூ தான் வரும்.
Then with that can be sure.
அதே தானே ஆல்மோஸ்ட் பண்ணியிருக்கோம் நம்ம ரேடியஸ். வேற வேற வேல்யூ சப்ஸ்டிடியூட் பண்ணி பார்க்கலாங்கிறியா? Finished the sixth question? All of you, Saravanan?
Yes, ma'am.
A 12 picofarad capacitor is connected to a 50-volt battery. How much electrostatic energy is stored in the capacitor? If another capacitor of 6 picofarad is connected in series with it, with the same battery connected across the combination, find the charge stored and potential difference across each capacitor. A 12 picofarad capacitor is connected to a 50-volt battery. How much electrostatic energy? That part is very simple. What is the formula? Electrostatic energy stored in a capacitor when the voltage is given 1 by 2 1 by 2 CV square. Calculate the first part. How much energy is stored in the capacitor? Half CV square. Minus 12. 12 into 10 power minus 12. Into 50 square, so much joules you will get. How much did you get? Huh? Minus 12, yeah. 15,000. 15 into, check for the power of 10. 15 into 10 power minus 9, correct. Minus 9 joules, so much. And it is connected in series with 6 picofarad. Series formula 1 by CS is equal to 1 by C1 plus 1 by C2. So for this part, now what will be the new capacitance? 1 by CS is equal to plus 6. Pico. Sorry?
They given only 12 picofarad.
Picofarad. Previous was 6 picofarad. 12 and then 6. 6 12 series la podrom. So formula 1 by CS is equal to 1 by 6 plus 1 by picofarad common இருக்கும். Final answer will be in picofarad. நீ numbers மட்டும் போட்டாலே போறோம். 1 by 6 1 by 12 அத போடு. 1 by 6 1 by 12 போடு.
Energy வந்து 5 into 10 to the power
72 divided by 18. Reciprocal எடுக்கணும். 72 divided by 18. 4 வருதா? 4 picofarad you are getting. So CS கிடைச்சிருச்சு. You got CS. CS is equal to 4 picofarad into 10 power. Then, and it is connected with the same battery combination. Find the charge stored and the potential difference across each. Series la connect பண்ணா என்ன சேமா இருக்கும்? What is the difference between series connection and parallel connection? Series connection la ஒரே current flow ஆகும். Charge on both the capacitors will be same. Parallel connection கொடுத்தோம்னா potential difference will be same but current will be different. So same charge on both because they are connected in series. So charge எதுல வேணா charge கண்டுபிடி and the charge is going to be same. Find the potential difference across each. That will change. Q is equal to CV. Q is equal to CV. அதை வச்சு C1 க்கு V1 ங்கற பொட்டன்ஷியலும் C2 க்கு V2 ங்கற பொட்டன்ஷியலும் கிடைக்கும். But charge will be same. Let's find out the charge. Charge is CV. Final effective கிடைச்ச 4 picofarad. 4 into 10 power minus 12 into how much is the voltage? 50. Charge is common for both. Q is equal to 4 into 10 power minus 12 into 50. Yes, 2 into 10 to the power minus 10 what? Coulombs. So that is the same charge for the other one also. Charge is same for both. ரெண்டோட கெபாசிட்டன்ஸும் தனித்தனியா தெரியும். So find the potential difference. C1 தெரியும், C2 தெரியும். காமனா இருக்கிற Qவும் தெரியும். Find out V1 and V2. Gautam. Common Q is equal to C1 into V1. C1 எவ்வளோப்பா? 12. And C2 is 6. Q எவ்வளோ? இப்போ calculate பண்ணுவோம். 2 into 10 power minus 10 கூடும். அதை வச்சு V1 தனியா V2 தனியா கண்டுபிடி. Find out V1 and V2. Now you know the values of Q, C1, C2. Find out V1 and V2. Because they are in series, charge is going to be the same. Effective இருக்கிற capacitance into effective voltage, C into V. Sorry, Q divided. Saravanan, are you there?
Yes, ma'am. Yes, ma'am.
So how much do you 12 picofarad எவ்வளோ வருது potential? 16.6666. So 16.67. 16.67 volt. Correct? 2 into 10 power minus 10 divided by இது மேல போச்சுனால என்ன ஆகும்? 10 power 2. 1 by 6. 1 by 6 can be written as 1. Yeah, 16.666. 100. 100 divided by 6 னு வரும். 100 divided by 6. So 10 the one time carry over. And what is the potential on the second one? 33.33. 33 point இதனோட டபுள் வரும். Because அதுல வந்து 12 picofarad இருந்தது the denominatorல இங்க வந்து 6 picofarad. So you will get exactly the double 16.666 ஓட double, that is 33.33 volt. Don't forget the units ma. Charge நாலும் சரி energy நாலும் சரி work done எல்லாத்துக்கும் யூனிட் போடு. Please put the units for everything. So once again, what are the answers? Electrostatic energy எவ்வளவு கிடைச்சது? 15 into 10 power minus 9. Are you checking your answers, Pratap? Pratap, are you checking? Are you checking your answers? Yeah. Electrostatic energy, your answer is, once again I'll tell you, electrostatic energy 15 into 10 power minus 9 joules. Then total charge on both the capacitors. Charges are the same. எவ்வளவு கிடைச்சது? 2 into 10 power minus 10 coulomb. First capacitor C1 la irundha potential V1 is 16.67 volt and second capacitors la 6 picofarad la வந்து 33.33 volt. Checked all the answers? Yes. Hemant, are you writing? Next one, an electric dipole of length 2 centimeters placed with its axis at an angle 60 degree to a uniform electric field of value 10 power 5 Newton per coulomb. If it experiences a torque 8 root 3 Newton meter, calculate the magnitude of the charge on the dipole and the potential energy of the dipole. What is the formula for torque acting on an electric dipole placed in a uniform? Tau is equal to, yes, PE sin theta. So what are the values that they have given? They have given the value of tau. Torque they have given 8 root 3 Newton meter. Then what else they have given? They have not given P, but they have given length 2A they have given. Then theta they have given. Electric field is also given. All you have to do is calculate Q. Q is equal to 8 into minus 5. 10 power la தான் எப்பவுமே தப்பு பண்றீங்க. Minus 3 coulomb. Now second, find the potential energy. Two way தான் எடுக்கணும். ஆமா, it's not half distance எல்லாம் தர மாட்டாங்க. கொடுத்திருக்கிற distance 2A எடுக்கணும். So never make that mistake. Whenever they say the distance between the two charges, that distance itself is taken as 2A. Don't think that A is 2 centimeter. 2A than 2 centimeter. Okay. Yes.
Q is equal to 8 into 10 minus 3 coulomb.
Minus 3 coulomb. Correct. Eight root 3 is equal to Q into 2 centimeters. So 2 into 10 power minus 2 into electric field is 10 power 5 sin 60. Sin 60 is root 3 by 2. Root 3 gets cancelled. 2 gets cancelled. So Q is equal to, here you have 10 power 3. So 8 into 10 power minus 3 minus 3. Plus 3 இந்த பக்கம் போயிடுறது இல்ல power. Now for potential energy formula, U is equal to minus PE cos theta. Calculated P, Q into 2A, calculated here. Yes.
is equal to minus 8 into 10 to the power
minus
8 into the power minus 5.
10 power minus 5. வெறும் minus 8 தான் வரும். செக் பண்ண minus 8 வெறும் minus 8 ஜூல். எந்த பவரும் வருது இல்ல. √3 ஏன் வரும்? cos 60 is 1/2 ல. sin 60 தானே √3/2. வெறும் minus 8 மட்டும் தான் வரும். Yeah. Yes, ma. Minus charge or value என்ன கிடைச்சது 8 into 10 power minus 3 into 2 into 10 power minus 2 into 10 power 5 into 1/2. Cos 60 is 1/2. So 10 power minus 3. So final answer is minus 8 joules. Ivan, you got all the answers. Ivan. Next question. Calculate the equivalent capacitance between the points A and B in the given circuit. A and B. The diagram is clear. Varshita, Shri, are you working? 4/3. See here you have 4 microfarad, 2 microfarad, 4 microfarad. All the three are in series. Similarly, this 4 and 2 microfarad, they are in another series. Where a series la. Tani answer kandupidichittu both the answers you have to calculate, consider as parallel.
Ma'am, can you please show the previous question one more time?
An electric dipole of length 2 centimeter is placed with its axis making an angle 60 degree to a uniform electric field of 10 power 5 Newton per coulomb. If it experiences a torque of 8√3 Newton meter, calculate the magnitude of the charge and the potential energy of the dipole. Next question. Okay.
Yes, ma'am.
Now, if you cannot see, this is 4 microfarad. You have a junction here. You have 4 microfarad here. Two microfarad. Then you have 4 microfarad here. Yeah. Let me check. Here you have 4 microfarad. 2 microfarad. You have a terminal here. Here you have E. So 1/4 plus 1/2 plus 1/4. 1/1 na 1 microfarad varum. In the mono seta. In the mono capacitance oda effective capacitance vandu 1 varum. 1/4 plus 1/2 plus 1/4. நீ கீழே இருக்கிறது 1/4 plus 1/2 3/4 வரும். So this 1 microfarad and 3/4 they are in parallel. Sorry, 3/4ங்கிறது 4/3 னு வரும். ரெசிப்ரோக்கல் எடுக்கணும். 4/3 microfarad. இந்த ரெண்டோட ஆன்சர் effective answer will be 4/3. And then add 19 by final answer எல்லாத்துக்கும். No, not 19. இதுக்கு மட்டும் தான் 4/3, அதுக்கு 1. இதை ரெண்டையும் சேர்த்துட்டு அப்புறம் இன்னொரு 4 வேற இருக்கு. தட் இஸ் இன் சீரீஸ். One second, let me check. இதுக்கு எவ்வளவுமா கிடைச்சது? இது ரெண்டு ஆட் பண்ணோன்னே 7/3. So 7/3 microfarad. It is in series with what? 4. So take the reciprocal. 3/7 plus 1/4. 28/19 you're getting. So 28/19. Reciprocal எடுக்கணும் இல்லையா? Final answer you have to take reciprocal here. அப்போ 7 எங்க? 1/3/7. 1/7/3. ஆமா, அதனால தான் 3/7 எடுத்தேன். இது ரெண்டு டைரக்ட் ஆட் பண்ணா போறோம். சோ என்ன வரும்? 7/3 வந்தது. அது ஏன் ரெசிப்ரோக்கல்? அது சும்மா அடிஷன் தானே, பேரலல் தானே. அங்க ரெசிப்ரோக்கல் எடுக்க கூடாது. அங்க ரெசிப்ரோக்கல் எடுக்க கூடாது. 7/3 தான் வரும். அங்க வெறும் 7/3. See this portion alone you are getting 7/3, correct? அது வரைக்கும் வருதா? Are you getting? Devadarshan, Saravanan, Harshita Sri, please switch on your cameras. In the portion வரைக்கும் you got 7/3 microfarad. In the region வரைக்கும் 7/3 வந்ததா? Then you have ஒரு 4 in series. So 7/3 should be written as 3/7. 4 should be written as 1/4. So you get 19/28. அதனோட reciprocal. 28/19 microfarad. Who's not getting? கிடைக்கலையா? இது வரைக்கும் 1 microfarad easy. இந்த மூணு சேர்த்தா 1. இந்த ரெண்டு தனியா சேர்த்தா 4/3. So இந்த 1 4/3 that you have to finish this one. Shall we go for the next question? 10th one. 10th already நீங்க சால்வ் பண்ணிருக்கீங்கன்னு நினைக்கிறேன். எதுமா? 10th question வந்துட்டியா? 1.8. 1.8 into. I think this one you did in the previous class. Try once again. Two positive charges. Those have not done, please do. All you have to do is, இதுக்கு எந்த formula use பண்ணணும்? W is equal to the charge that is being moved into difference in potential. Final minus initial. 10 power minus 4 joule, correct. What is RF? 1 divided by RF is 0.05. Yeah. First வந்து எதை மூவ் பண்றியோ அது small q. எதோட potential இருக்கோ that is taken as capital Q. Q1, Q2. Q1, Q2 also you can take, no problem. Interchange பண்ணாலும் ஒன்றும் வராது. One is your source, the other one is what your RF is 0.05. No, 10 centimeter, 0.1. Check your final answer will be 1.8 into 10 to the power minus 4 joule. Five centimeter, 5 divided by 100, 0.05. This is 5 centimeter and this is 10 centimeter. Initially the distance was 10 and the final distance is you brought it to a 5 centimeter. All of you got the answer?
Yes, ma'am.
Sorry, one second. The live, right?
Yes.
So I just came for one small announcement. I think you already have got the message in the group also. This Sunday we are starting our NEET and JEE batch. So this Sunday, I hope you're able to hear me, those who are in online. Am I audible to you? Yeah.
Yes, sir.
So this Sunday we are starting our NEET and JEE batch. It is once again going to be hybrid. That is, you can have option of attending online as well as offline. Same studio will have the classes. So the class timing will be from morning 8 o'clock till afternoon 12:30 p.m. The class timings will be sent to you in the group also, and all the procedures will be sent in the group. Those who want to come for the demo class can come for the first 2 Sundays. That is on 13th and on 20th. Then you can decide whether you want to join or not. But first 2 Sundays, that is this Sunday, which is 13th and 20th, are demo class days. Anybody who wishes to see the NEET and JEE classes can come if you are interested. Condition is very bad. AC not working. There it is cold little. Only here it is fine. Thank you. Sorry.
So finish the 10th question. All of you got 1.8 into 10 to the power minus 4 joules. You got the answer? You in the lesson line எடுக்கவே இல்லையா? Then you should have gone there, no? தெரியலையா அங்க? அப்போ அவன் சொன்ன போவாத போயிருக்கலாம்ல. Minus 3 here. How come? This is 9 into 10 power 9. Then 0.2 into 10 power minus 6. 0.01 into 10 to the power minus 6. Closer. Shall we go for the next question, section C? Obtain the expression for potential due to a point charge. How will you calculate? How will you derive the potential due to a point charge? How will you define potential? Potential is defined as the work done to bring unit positive charge from infinite distance to the particular point. Let it be R. Then how will you calculate? Work done is equal to force into distance. Derive, it's a derivation. question number 10 வரை முடிச்சாச்சா? Now derive the expression for potential due to a point charge. So R2 na என்ன டிஸ்டன்ஸ்ல இருந்தது, என்ன டிஸ்டன்ஸ்ல இருக்கு? ஃபைனல் மைனஸ் ஃபைனல் வந்து 5, இனிஷியல் வந்து 10. So imagine that you already have a charge plus Q placed here, and you're going to find the potential at a point P, which is at a distance R from the given charge. Now, you're bringing a test charge Q0 from infinity to a point. Let it be moved through a small distance dx. You will calculate the work done to move a small distance dx, then you will integrate it for infinity to the point R. First, you will calculate the small work done to move it through a small distance dx. அதுக்கப்புறம் என்ன பண்ணுவோம்? அந்த dw ஃபுல்லா இன்டகிரேட் பண்ணுவோம். என்ன லிமிட்ஸ்ல இருந்து? இன்ஃபினிட்டில இருந்து R வரைக்கும். So this is your test charge. Already there is a source charge plus Q. Are you writing or not? So நம்ம என்ன பண்ணணும், அந்த டெஸ்ட் சார்ஜை மூவ் பண்ணும்போது you have to do work against the potential. இந்த plus Q ஒரு potential exert பண்ணும் at this particular point. அந்த potentialக்கு against you're doing work. Let the small work done be dW. dW is equal to force into the small distance dx. So அந்த பாயிண்ட்ல xங்கிற பாயிண்ட்ல என்ன ஃபோர்ஸ் இருந்திருக்கும்? 1 by 4 pi epsilon naught kq னு போட்டுக்கோ. 1 by 4 pi epsilon naught both the charges q naught divided by x square into dx. Now by definition potential is defined as the work done to move unit positive charge. So q naught oda value enna edukanum? Q naught oda value should be taken as 1. Your test charge should be 1 unit positive charge ah irukanum. Then so dw is 1 by 4 pi epsilon naught q divided by x square into dx. This is a small amount of work done to move through a distance dx. So total distance ka w is equal to integral dw between the limits infinity to r, from infinity to r. So integral infinity to r k q by x square dx. What is 1 by x square dx? Integral 1 by x square dx is integral 1 by x square dx. Answer என்ன? என்னமா? ஆமா ஆமா q0 என்ன எடுத்துக்க சொன்னேன்? யூனிட் பாசிட்டிவ் சார்ஜ் 1 ன்னு எடுத்துக்கிட்டோம். அதனால q மட்டும் வருது. டெஸ்ட் சார்ஜை வந்து யூனிட்டா எடுத்துக்கிறோம், 1 ன்னு எடுத்துக்கிறோம். So you get minus k q by x between the limits infinity to r. So kq by x sorry kq காமனா வெளியில எடுத்துட்டோம்னா minus kq எடுத்தோம்னா upper limit 1 by r minus 1 by infinity. Upper limit minus lower limit. Upper limit minus lower limit தானே? Potential minus இதனோட ஒரு மைனஸ் வேற வருதுல்ல ஏற்கனவே இங்க ஏற்கனவே ஒர்க் டன் இஸ் நெகட்டிவ் பிகாஸ் யூ ஆர் டூயிங் ஒர்க் அகைன்ஸ்ட் இட், அதுக்கு ஒரு நெகட்டிவ் இருக்கும். இப்போ இன்டகிரேஷன்ல வந்த நெகட்டிவும் சேர்த்து இட் will become positive. See here the work done is negative. Why? Because you're doing work against the force. So this work done will already be negative. So இங்க ஒரு நெகட்டிவ் வரும் and integrationல வந்த நெகட்டிவும் சேர்ந்து this will become positive. After integration you will get one more negative. So kq into 1 by r minus 1 by infinity. So your final answer will be kq by r. Potential due to a point charges V is equal to kq by r. You write with explanations, diagram போட்டு proper explanations எழுது. q naught வந்து test charge, q வந்து source charge. q naught என்னன்னு எடுத்துக்கிறோம்? நவீனா, S சரவணன், are you there? நவீனா, and capacitance of a unit another 1 farad. 1 farad is defined as formula q by v. So 1 farad is the capacitance of a capacitor which can produce a potential of 1 volt when a charge of 1 coulomb is provided to it. That is how it is. So k oda value போட்டேனா என்ன வரும்? V is equal to final answer 1 by 4 pi epsilon naught q by r. Use the above expression to show that the potential due to a dipole varies as the inverse of the distance r of the field point from the center of the dipole for r greater than a. We are asked to calculate the potential of a dipole. Show that the potential due to an electric dipole varies as inverse square of the distance. Minus q here, plus q here. What is the distance? 2a. You have done this derivation? Random or point at the field dilemma, distance of the field point. Show that the potential due to an electric dipole varies as inverse of the square of the distance r. They have asked potential, total potential they have asked due to a dipole. Random or point at the P. Let it be at an angle theta. So in this side another angle 180 minus theta. Random both axial, equatorial, ella cases எடுத்துடலாம். You want to do in the axial? Axial கொடுத்திருக்காங்களா? Okay, then take axial. Take any point C. This distance is A. Distance of C from this point, let it be R. Farad. It is the capacitance of a capacitor if it produces a potential of 1 volt in it when a charge of 1 coulomb is applied to the capacitor. You give a charge of 1 coulomb and it produces a potential, it develops a potential of 1 volt, then that capacitance of the particular device is defined as 1 farad. Now what will be the total potential at the point C? ரெண்டு பொட்டன்ஷியல் இருக்கு, நெகட்டிவோட சார்ஜோட பொட்டன்ஷியல் as well as பாசிட்டிவோடது, அதை ரெண்டும் சேர்த்துக்கணும். இட்ஸ் ஸ்கேலார், ஸோ டைரக்ஷன் வராது, டிஸ்டன்ஸ் மட்டும் தான் கன்சிடர் பண்ணும். ஸோ வி டோட்டல் வில் பி ஈக்குவல் டு வி பிளஸ் பிளஸ் வி மைனஸ். ஸோ வி பிளஸ் என்ன வரும்? What is the potential due to the positive charge? R minus A, K Q by R minus A வரும். இது negative charge, so minus K Q by R plus A. Now cross multiply. R plus A minus R minus A divided by R square minus A square. So R gets cancelled, 2A வரும், 2K Q A by R square minus A square. Now what is 2QA? P. So it is magnitude of electric dipole moment divided by, now if A is very much less than R, you can neglect A square. A square can be neglected and finally you get R square. KP. KP by R square. So it is inversely proportional to square of the distance. Correct? மென்ஷன் பண்ணல, அதனால தான் நான் 3 கேசஸுமே எடுக்கலான்னு பார்த்தேன். ரேண்டமாக ஒரு பாயிண்ட் பி எடுத்தோம்னா டீட்டாக்கு வேல்யூஸ் போடணும். டீட்டாவை வந்து சப்போஸ் டீட்டா 0, இட் வில் பி இன் தி ஆக்சில் லைன். டீட்டா 180 இருந்தாலும் ஆக்சில் லைன், பட் டுவர்ட்ஸ் மைனஸ் கியூ வரும். அண்ட் டீட்டா 90 இருந்தால் இக்விட்டோரியல் லைனில். ஆல் தி 3 கேசஸ் போட்டு பண்ணலாம், பட் அது டிடிஎஸாக ரொம்ப லெங்க்தியாக போகும். போடவா? ஆக்சுவலி அப்படி போடும்போது வாட் யூ கெட் இஸ், சி if you take like this, theta னு எடுத்தோம்னா final answer will be k p cos theta by r square னு வரும். thetaக்கு 3 cases போட்டு axial lineல towards plus q, towards minus q and midpointல 3 casesமே கிடைக்கும். midpointல you will get 0 also because cos 90 is 0. so ரெண்டு chargesக்கு நடுவுல exactly centerல the potential will be 0, it will be cancelled. you got all of you? See, V total is V negative plus V positive. V negative oda distance vera, V positive oda distance vera. Then you substitute as P, electric dipole moment divided by R square. So you are proving that the potential varies as square of the inversely proportional to square of the distance. Clear? Next question. Define the SI unit of capacitance. What is SI unit of capacitance? Farad. 1 farad. It is defined as the capacitance of a capacitor. When a charge of 1 coulomb is provided to it, it produces a potential difference of 1 volt. அப்படி இருந்ததுன்னா அந்த கெபாசிட்டரோட யூனிட் வந்து 1 farad இருக்கும். கெபாசிட்டர்ங்கிறது டிவைஸ், அதனோட கெபாசிட்டன்ஸ் எப்படி டிஃபைன் பண்ணுவோம்? Suppose you are supplying a charge of 1 coulomb to the capacitor and it produces a potential difference of 1 volt between the two plates, then we define as the capacitance of the given capacitor is 1 farad. Obtain the expression for capacitance of a parallel plate capacitor. Derive first one. 17th one. கீழே இருக்கிறது ஒன்று பாசிட்டிவ் ஒன்று நெகட்டிவ் தானே, மேலே இருக்கிற ஏ மேலே தான் கேட்டிருக்காங்க ப்ளஸ் கியூ. ஸோ ஒன்று ரிப்பல்சிவாக இருக்கும், ஒன்று அட்ராக்டிவாக இருக்கும். அதனோட ரிசல்டன்ட் கண்டுபிடிக்கணும். வெக்டார் ஃபார்முலா root of f1 square plus f2 square plus 2f1 f2 cos theta. Finished. Obtain an expression for capacitance of a parallel plate capacitor. Can I erase this one? Now how will you derive the capacitance of a parallel plate capacitor? C is equal to Q by V, and V is equal to electric field into distance. V is equal to E into D. C is equal to Q by V, but V is equal to electric field into distance between the two plates. Now what is electric field due to a parallel plate capacitor between the two plates? What is the electric field? Sigma by epsilon naught. So E between the plates is equal to sigma by epsilon naught. So here you can write Q divided by sigma by epsilon naught, that goes to the numerator, into D. Now what is sigma? Sigma is equal to Q by area. So C is equal to epsilon naught A by D. Derive the expression for effective capacitance of a series combination of n capacitors. Finish this one. Now for the third question, third subsection. What is the speciality of connecting in series? What will be same in all the capacitors? Charge will be same. So consider n capacitance such that the capacitance of each capacitor is C1, C2, C3, etc. Can I erase this one? Distance automatically கம்மி ஆகுது, நம்ம கம்மி பண்ணணும். Yeah, draw the diagram. So let the capacitors be C1, C2, C3, etc. It is connected in series with a potential, say V. Amount of work done. W is equal to Q into V. Which one are you asking? 17th one. Potential difference between which two? Work done to separate the charges from. Yeah, once again I'll solve this one. So you have a lot of capacitors in series C1, C2, C3, etc. Now all will be having the same charge Q. Now Q is, but they will have different potentials. What? C1 will have a potential, say V1, this will have a potential V2, V3 and so on. So Q is equal to, what is getting divided here? Potential is getting divided. So the total potential V is equal to individual potentials of the capacitors, that is V1 plus V2 plus V3 and so on. Now this V is the total potential and it is equal to, Q is equal to CV. Q is equal to CV. Inga Q is the total charge, C is the effective capacitance and V is the total potential that you have supplied. So total potential V is equal to Q divided by CS. So V ki badla enna eduthalam, Q divided by CS you can write. V1 ku badla, instead of V1 what can you write? Q by C1. Q by C1 plus Q by C2 plus Q by C3 and so on. So common ella Q velila eduthalam, Q and Q gets cancelled. So the final answer will be 1 by CS is equal to 1 by C1 plus 1 by C2 and so on plus 1 by Cn. So here you are using the logic that potential potential will be divided. V will be equal to, Gautam, are you writing? V will be equal to V1 plus V2 plus V3 and so on. Aila V ingirudhu total charge divided by the effective capacitance in series, which is taken as CS. Then Q divided by C1 plus Q divided by C2. V1 is taken as Q by C1, V2 is taken as Q by C2 and so on. Common Q it can be cancelled. You get 1 by CS is equal to 1 by C1 plus 1 by C2 plus etc. Potential energy. Finished all of you? Saravanan finished? Shakti Vel?
Finish, ma'am. Completed, ma'am.
Shall we go for the next question? Capacitance is the electrical property of a capacitor and is a measure of capacitor's ability to store an electrical charge onto its two plate. A capacitor is an arrangement for storing a large amount of electric charge and hence electric field in a small place. The capacitance of 1 microfarad equals 1 microfarad, 10 power minus, what are the options? Option A is 10 power minus 8, option B is 10 power minus 12, option C 10 power minus 4 farad, and last one is 10 power minus 6 farad, micro. The capacitance between the two plates increases with, what was the equation? C is equal to epsilon naught A by D. Epsilon naught is a constant. So it depends on, it is directly proportional to area and inversely proportional to the distance between the two plates. So which option is the correct one? A. You require a larger plate area and a shorter distance between the two plates. Option A is larger plate area and shorter distance between the plates. Option 2 is larger plate area but longer distance between the plates. Option C is shorter plate area, shorter distance between the two plates. And last option is shorter plate area and higher applied voltage. A. Option A. Yes, ma'am. Complete. Wait. Oh, wait. Capacitor stores which type of energy? Potential energy. You have finished the previous one. Aniki kudutadla edo baki irukadla. Where is that? Capacitor stores which type of energy? Potential energy, vibrational energy, kinetic energy, none of these.
Potential energy.
Potential energy, electrostatic energy or electrostatic potential energy. If there is an option electrostatic potential energy, go for it. This one. Yes, ma'am. You want that paper to solve the previous weeks? You've solved all the questions in that one? You should have brought it now. I have it with me. I think the Kirchhoff's, this comes as a combination of current, electricity, and that also you have to choose. So go for this one. 3-point charges Q, minus 4Q and 2Q are placed at the vertices of an equilateral triangle. ABC having a side L as shown in the diagram. Obtain the expression for the magnitude of the resultant electric force acting on the charge Q. Yeah, K Q1 Q2 by R square. What are the two forces experienced by Q at the point A? It will experience a repulsive force due to plus 2Q and an attractive force due to minus 4Q. Draw the diagram first. You will have two forces. One force will be repulsive force, the other force will be attractive force. So here Q will experience a repulsive force due to 2Q and it will experience an attractive force due to minus 4Q. So what will be a resultant force? Resultant force will be in this direction. What is the angle between equilateral triangles? So if this is 60, yeah, the whole angle will be 120 degree. Calculate this force, let it be F1. Calculate F2 also. Then your total resultant force will be equal to root of F1 square plus F2 square plus 2 F1 F2 cos 120 degree in this case. Cos theta, cos 120 in this case. Calculate F1 taniya, F2 taniya. Kandupidi. F1 எவ்வளவுமா வருது? They have not given Q லே கொடுத்திருக்காங்க. So write it as in terms of Q எழுது. K Q1 Q2 K Q square by R distance L கொடுத்திருக்காங்களா? L square F ன்னு எடுத்துக்கோ ஜெனரலா. Okay, அங்க என்ன வரும்? In the attractive force will be K into minus 4Q square divided by L square. F1 என்ன வரும்? This will be F2. F2 will be minus K 4Q square divided by L square. Repulsive force என்னவா இருக்கும்? K into 2Q square divided by L square. Take this as F1, this as F2.
Shall we consider F2 as 2F1?
In the KQ square by L square, F ன்னு எடுத்துக்கோ ஜெனரலா. K Q square by L square can be taken as F. So this can be written as minus 4F. This can be written as 2F. Now try. ஒண்ணுக்கு minus 4F ன்னு எடுத்துக்கோ, இன்னொன்னுக்கு 2F ன்னு எடுத்துக்கோ. Take it as minus 4F and 2F. So squaring minus 4f square பண்ணோம்னா 16f square, 2 square பண்ணோம்னா 4f square, 2 add பண்ணா 20, then 2 into 4 into 8, cos 120 is minus 1 by 2, so negative becomes positive there. அப்புறம் இங்க வந்து 20f கிடைச்சதா 20f அப்புறம் ரூட் ரூட் 3f தானே வருது ரூட் 3 16 plus 4 plus 4 2s are 8 2s are 16 வராது 8 தான் வரும் ஸோ இங்கே மைனஸ் 4f எடுத்தனா 16f ஸ்கொயர்னு வரும் 2f எடுத்தனா 4f ஸ்கொயர்னு வரும் 16 plus 4 is 10 sorry 20 and then 2 cos 120 அங்கே வந்து minus 8f square இது 16f square uh, 12f square வரும் it's just root 3 it's given f1 is equal to f2 they have given yeah root 3 4 root 3 yeah 2 root 3 yes 16 8 12f square னு வருது ரூட் பண்ணோம்னா என்ன வரும் 4 root 3 sorry 2 root 3 4 into 3 so 2 root 3 வரும் 2 root 3 f அப்படின்னு வரும் instead of f you can write kq by kq square by l square 2 root 3 k q square by l square this will be your answer 2 root 3 kq square by l square last question 4 charges are arranged at the corners of a square ABCD of side D as shown. Find the work required to put together this arrangement. Total potential. Work done to separate the charges at infinite distance. That will be equal to the total potential energy of the system. Total potential energy of arranging Q minus 4Q and 2Q. எந்த ஆர்டர்ல வேணா அரேஞ்ச் பண்ணலாம். See, what is the total potential energy of the system? Please listen, ma. What is the total potential energy of the system அப்படின்னு கேட்கும்போது you could have arranged Q first. Suppose இந்த சிஸ்டத்துல வேற எந்த சார்ஜுமே இல்லை அப்போ Q தான் முதல்ல கொண்டு வரேன்னா work done to assemble Q at that point is 0. Then you are bringing minus 4Q. It will have to overcome the potential due to Q. So என்ன வரும் U is equal to K Q1 Q2 by R, that distance. So K into minus 4 Q square by L square னு வரும் அந்த distance, அந்த potential energy work done. Then அதுக்கப்புறம் when you are assembling 2Q also it will have to overcome the potential due to Q as well as minus 4Q. ரெண்டு term extra வரும். First, what is the work done to arrange plus Q?
When we substitute 40, we take the minus 40. We take magnitude or sign?
No, you take sign மட்டும்தான். Sorry, magnitude மட்டும்தான், not sign.
Magnitude.
Magnitude alone. Magnitude. U is equal to Q1 Q2 na both you have to take sign as well as magnitude. Negative na negative எடு, positive na positive எடு. So the total potential energy of the system, listen ma. Yeah, one second. The total potential energy will be equal to the work done to assemble the charge Q plus work done to assemble the charge minus 4Q, then work done to assemble the charge 2Q. இதுக்கு வந்து 0. Then minus 4Q கொண்டு வரும்போது K minus 4Q into Q divided by L square. இங்க வந்து ரெண்டு term வரும். What are the two terms? K minus 4Q into 2Q divided by not L square, L. It's not L square, it is L. Here also the distance is L. One more term you will have what? K Q into 2Q divided by L. So எல்லாத்துலயும் common என்ன இருக்கு? Q square, K Q square by L you can take out common. K Q square by L. So இதுல என்ன வரும்? Minus 4, then here minus 8 and then plus 2. So final answer will be minus 10 K Q square by L square. Sorry, L. L square. L, not L square. This is the total potential energy of the system. Now last question. Four charges are arranged at the corners of a square ABCD of side D as shown in the diagram. Find the work required to put this arrangement together. Same அதே மாதிரி தான் பண்ணணும். Plus Q arrange பண்றதுக்கு plus Q. Initially suppose you had brought plus Q in the first stage. அப்போ total work done was 0 அதுக்கு. இதுக்கு வரும்போது இது ரெண்டுக்கும் நடுவுல இருக்கிற interaction. Plus Q க்கு வரும்போது இந்த ரெண்டோட நடுவுல இருக்கிற interaction with the distance. இது ரெண்டுக்கும் என்ன distance எடுப்பேன்? This you will take it as D root 2 or root 2 into D. இதுக்கு முன்னாடி பண்ண சம் பண்ற மாதிரியே தான் பண்ணோம். டிஸ்டன்ஸ் எல்லாம் it is given D root 2 D diagonal. A charge Q0 is brought to the center E of the square. The four charges are being held fixed at its corner. How much extra work is needed to do this? இப்போ ஏற்கனவே நீ கண்டுபிடிச்ச ஒர்க் டனோட வேற என்ன பண்ணோம்? இந்த Q0 க்கு ஒன்னொன்னோடயும் இருக்கிற interaction you have to find out. Suppose you have brought Q0 at the center. Q0 will interact with Q0 a positive னு எடுத்துக்கலாம். Q0 will interact with plus Q, minus Q, this minus Q as well as plus Q. And what will be the distance? All the distances will be equal. D root 2 by 2. D root 2 by 2. It is exactly at the center. So the distance between the test charge that you're placing at the center and to the corners will be same. D root 2 by 2. The ஒன்று மட்டும் work பண்ணுங்க. How much extra work is needed to do this? In the, yeah, over ma. Yeah, completed and then you can send the assignment. Next class la நான் இதை check பண்றேன். And அது முன்னாடி முடிக்காதது இருந்தா, if you are having the previous assignment, please complete. அல்ல முடிக்காதது section B, D, anything you have. Yeah, thank you ma. Submit your notebooks. All of you submit your notebooks. Niranjan, submit your notebooks. Yeah, all of you submit your notebooks. Nee venda.